The Foundations of Geometry by David Hilbert. Chapter 5, Desargues' Theorem. Section 24, Introduction of an Algebra of Segments based upon Desargues' Theorem and independent of the axioms of congruence.
In order to see fully the significance of Desargues' theorem, Theorem 32, let us take as the basis of our consideration a plane geometry where all of the axioms, groups 1, 1 and 2, groups 2 and group 3, are valid. That is to say, where all of the plane axioms of the first three groups hold, and then introduce into this geometry, in the following manner, a new algebra of segments, independent of the axioms of congruence. Take in the plane two fixed straight lines intersecting at O, and consider only such segments as have O for their origin and their other extremity in one of the fixed lines. We shall regard the point O itself as a segment and call it the segment O. We will indicate this fact by writing OO equals 0 or 0 equals OO. Let E and E prime be two definite points situated respectively upon the two fixed straight lines through O. Then, defining the two segments OE and OE prime as the segment 1, and write accordingly OE equals OE prime equals 1, or 1 equals OE equals OE prime. We will call the straight line EE prime for brevity the unit line. If, furthermore, A and A prime are points upon the straight lines OE and OE prime, respectively, and if the straight lines AA prime joining them is parallel to EE prime, then we will say that the segments OA and OA prime are equal to one another and write OA equals OA prime, or OA prime equals OA. In order now to define the sum of the segments A equals OA and B equals OB, we construct AA prime parallel to the unit line EE prime and draw through A prime a parallel to OE and through B a parallel to OE prime. Let these two parallels intersect in A double prime. Finally, draw through A double prime a straight line parallel to the unit line EE prime. Let this parallel cut the two fixed lines OE and OE prime in C and C prime respectively. Then C equals OC prime is called the sum of the segments A equals OA and B equals OB. We indicate this by writing C equals A plus B, or A plus B equals C. In order to define the product of a segment A equals OA by a segment B equals OB, we make use of exactly the same construction as employed in section 15, except that in the place of the sides of a right angle, we make use here of the straight lines OE and OE prime. The construction is consequently as follows. Determine upon OE prime a point A prime so that A prime is parallel to the unit line EE prime, and join E with A prime. Then draw through B a straight line parallel to EA prime. This parallel will intersect the straight line OE prime in the point C prime, and we call C equals OC prime the product of the segment A equals OA by the segment B equals OB. We indicate this relation by writing C equal AB or AB equals C.
The Foundations of Geometry by David Hilbert. The material contained in the following translation was given in substance by Professor Hilbert as a course of lectures on Euclidean geometry at the University of Göttingen during the winter semester of 1898 and 1899. It was translated by E. J. Townsend, Ph.D., University of Illinois. The text was downloaded from Project Gutenberg with the following notice. This ebook is for the use of anyone, anywhere in the United States and most other parts of the world at no cost and with almost no restrictions whatsoever. Read by Jim Renholt. Programming and illustrations by Jim Renholt. 2019. Portrait of David Hilbert by Rita Ray Renholt. Thank you for listening.